Hello, my dear students, my dear J and NEET warriors. I hope you guys are able to see me and hear me properly. Do let me know in the chat box. And welcome to the next session of your CBSE 2024 board examination. And yes, today is a replica paper. It's almost like, getting to know what the paper is going to look like in advance. So let's solve this paper, and if you feel like, sir, I want to give these questions later on also and only watch the solutions, that is also perfectly fine. Okay, so let's begin with the class and let's see all the amazing questions. And if you have missed any of the previous sessions, please watch it. We started this 6-day challenge for the CBSE 2024 board examination with a proper strategy on day 1. Then we went on to graphs of all these chapters, from part 1 and part 2 of physics. We saw the equations, understood how these graphs look like and what is the reasoning behind them. Then we went to derivations of all the topics, for your CBSE Physics board examination. Then we went on to problem solving from all the chapters, right, yesterday. And today we are with the replica paper. Tomorrow we are going to have the final revision. Hello Shweta, hello Gaming with Alone Boy, hello Fanciful, Fables. What names you guys get? Yeah, I really I think I should ask for some nice titles for my next sessions from you people only. Your names are only so unique. I think I can also not think of such creativity. Hello Kim, nice to see you. Hello Dikshida, hello Bharat Tailoring, hello Shakti, good evening, good morning everyone. Hello Crazy Dude, hello Harshan, nice to see all of you. Hello Sandeep, Bhumika, all geared up full of energy and josh because I know you are tensed. And when somebody teaches, when somebody is solving problems, it feels nice because it feels like somebody is taking away half the load from you. So that is exactly the reason why I'm here. I could have asked you to just study on your own also whole day, but I feel sometimes you also need a person sitting in front of you who is doing something and you're just going with the flow. So that's the reason why I'm here. So let's just go with the flow. Let's solve as many questions as we can in this replica paper. Okay, so only reading the definition, derivation, diagrams, graph, and in textbooks back PYQ enough? Yes, fanciful peoples. That is exactly what you need to do. Hello Hari, hello Senthil. Good morning. Nice to see all of you. Chalo, let's begin with the class, and here comes the first thing. But before that, let me also tell you that in the description box there are some fancy, amazing links for your board exam preparation. Check those links out. Download them now. Join our Telegram channel. You'll be getting updates. Not just that, PDF links are there. So you can download all the previous session PDFs as well from Telegram, or just go into the description box of this video and the previous videos as well. So make sure all those PDFs are with you. If you have not yet created your free account at Vedantu, create it right now. You need it for accessing all the quality content at one place. Okay, so do that. Thank you so much. Yes, is the mega revision have problem solving? Mega revision tomorrow will not have so much of problem solving. It is more of formula and concept understanding and a little bit of problem pattern revelations and how to solve those kind of things. It's more of revision rather than anything else. Cool. Yes, so let's begin. And where are we? Where is my slide? Okay, yeah. Chalo, let's begin. Section A, 1 mark, MCQ, assertion reason type. Gear up for it. The questions are going to come up on your screen. Everybody with full josh and full energy, and smash the like button right now, because that's how you give your Guru Dakshina. Subscribe to the channel. When you give Guru Dakshina, the knowledge enters your head. If you don't give Guru Dakshina by smashing the like button, subscribing and commenting, then that knowledge might not stay in your head, and when you need it, will not be useful. So smash that like button right away, right now. You need that. Okay, a body can be negatively charged by what? One of the 4 options coming up on your screen. What do you think it is? A body can be negatively charged. You can watch it for boards, but if you are a NEET student, NEET 2024 student, obviously it will be useful. If you're a dropper, you can just have a look at it. I mean, instead of just sitting idle, if you have nothing to do, then please watch the session. But otherwise, if you think that you have a plan in mind, then for specially need students, so you can, if you're a dropper, that is, then no need to watch this session. But if you're a fresher, please watch it. Okay, yeah. A body can be negatively charged by giving excess of electrons to it, and many of you got the right answer. Very good, proud of you. The opening question warmed up already. So when you give excess electrons, the negative charges will pile up. When you take away the electrons, the body becomes positively charged. How many electrons must be removed from an electrically neutral metal plate to give it a positive charge of 10 to the power minus 7 coulomb? So we know that every electron has 1.6 10 to the power minus 19 coulomb. So multiply that with n, you will get the charge of 10 to the power minus 7 coulomb. So that will give you 6.25 into 10 to the power minus 11. So the way to do that would be basically writing 1.6 into 10 to the power minus 19, multiply it with n to get it as 10 to the power minus 7. So from this, you get the value of n as 6.25 into 10 to the power 11 number of electrons. The unit of permittivity of free space is, come on, my dear warriors. The unit of permittivity of free space is, okay, so for this, you can use the Coulomb's law formula. From that, you will get it. Bhaskar, yes, tomorrow it will be a long session, but today's session is very crisp and short. You can use this formula 1 by 4 pi epsilon naught q square by r square. So epsilon naught will be q square by 4 pi f r square. So you can see on the top you have Coulomb square, at the bottom you have Newton as well as meter square. So Coulomb square on the top, Newton and meter square below. So that's the answer. You can see that this is basically Coulomb square, and these two together, that will be Newton meter square below. That's it. Very good. That is the option number C, not option B. I think many of you put meter square on the top. No, it is not B. It is option C. Be careful. R square is below. Okay. It's not K value they have asked. They have asked you the value of epsilon. Gauss law is valid for any closed surface, regular closed surface, any open surface, only irregular open surface. What do you think it is? Come on, put up the answer in the chat box. 1 marker questions, MCQ, assertion, reason type, section A. Continuing on your YouTube channel, make sure you're subscribed to the channel as you're watching this video, as well as you're liking the video by giving this Guru Dakshina. Thank you so much. If you have done that already, start spamming the answer in the chat box. What do you think the answer is? Yes, very good. Many of you got it correct. The answer is any closed surface. It's not for regular closed surface or symmetrical closed surface. Yeah, we use Gauss law for symmetrical surfaces or for regular polygons as such, because it makes our job easy, but that doesn't prevent us from using it for any randomly shaped closed surface. The main criteria is the surface must be closed. That's why you use the closed surface integral. E vector dot dA vector is going to be q in divided by epsilon naught. So this is going to stand for the closed surface integral. Yes. So any closed surface. A spatial distribution of electric field. Let me just make myself a little bit small. Okay. Which of the following statement is correct? A is positive, B is negative. A is positive, B is negative. A, both are positive, both are negative. A is more than B, etc., etc. What do you think? Come on. This you'll have to think a little bit. Only then you'll get the answer. Think about it. Yes, the spatial distribution of electric field due to two charges is given. Many of you are saying B. Some of you are confused between A and B. Very good. Let me tell you, the answer is B. Many of you got it correct. See, always electric field lines start from a positive charge and at a negative charge. So A must be positive because the field lines must start over here and they must end over here. Count the number of field lines on A as well as B. You will see the number of lines entering B and exiting A are the same. Because they are same, that's why the magnitudes of the charges are going to be the same. Okay, I hope this is clear. Srinidhi, if you feel that there is some topic which you need clarity on, please watch my older classes. That is going to be okay. When air is replaced by a medium of dielectric constant K, the force of attraction between the two charges separated at a distance R decreases K times, remains unchanged, increases K times, increases K raised to minus 2 times. What do you think it is? When air is replaced by a medium, then the force, what happens? It becomes weak. It becomes weak because the field becomes weak. How many times does it become weak? It becomes weak K times, so it decreases K number of times. So hence, the answer is option A. It's not C. It does not increase. The capacitance increases K times. Capacitance. But the field force, all these things decreases K number of times. Okay, great. A point positive charge is brought near an isolated conducting sphere, which is the best diagram to represent it. Which is the best diagram to represent it. Come on, my dear warriors. Think about it. Yes. So basically these kind of questions I'm taking you to show you how the question paper questions look like. This is like a sample paper, but not on the official side. But this is, from our research or basically our question bank. I'm just giving you some sample questions so that you get a feeling of how the level will be. Are you able to solve it or not? You'll get the confidence. That's all. This is just a session to give you the look and feel of the actual exam. Okay, point positive charge is brought near a sphere. The electric field is best described by, well, the field lines on a conductor should always be perpendicular to the surface of the conductor, and there is only one such one such option like that. If you notice, in option number 2, what is the problem? On the positive charge, the field lines are terminating. Always on the positive charge, the field line should originate. It should not terminate. So that is the reason why option 2 becomes wrong. If you look at option number 3 and 4, what happens is the field lines are not even perpendicular. They are making some angle. So that is why that also becomes wrong. So only this particular option, from the positive charge, the field lines are exiting out and they are also perpendicular everywhere. So that is the reason why we have chosen option number A. A hemisphere is uniformly charged positively. The electric field at a point on a diameter away from the center is directed perpendicular to the diameter, parallel to the diameter, at an angle tilted towards the diameter, an angle tilted away from the diameter. What do you think? Yes, we're going to go to section B also. Don't worry. What do you think? Yes, a hemisphere uniformly charged positively. The electric field lines at a point on a diameter away from the center is directed where? The answer is perpendicular to the diameter. Hemisphere is uniformly charged positively. So basically think of this as the hemisphere. Okay, not so great. This is your hemisphere, which is charged positively. The electric field at a point on the diameter, basically away from the center. Away from the center, that means if you take a point somewhere over here, where will the electric field be exactly at that particular point? That is the question. So it is going to be somewhere over here, because all these positive charges are going to repel it. So basically the resultant of all these fields or the forces will come out somewhere in this direction. You can also think of it this way, that only if half of this is present, the field will be this way. If the remaining half of it is added back, then the field due to that part will be here, and then both of them will end up cancelling out each other to make the net field as 0. So that is the reason why they should be collinear. They should cancel out each other if the remaining half was present, because we know inside a shell the field is 0 everywhere. Okay, I hope this is clear. 2 point charges are at separation r. The force acting between them is given by k q1 q2 by r square. This the constant k depends on the system of units, only the medium between the charges, both a and b, neither a and b. What do you think of this? What do you think of this? Come on, my dear warriors. A second. Okay. Yep. Very good. It depends on what? Both. Many of you got it wrong. Many of you are going to lose marks over here. Be very careful. Guys, how is it only dependent on the medium? It is also dependent on the units, because the value of k, which is nothing but the value of k, which is 9 into 10 to the power 9, is in SI units. If I use CGS units, it will be different, because force will be measured in dynes, distance will be measured in centimeters, charge will be measured in ESU. So obviously the answer will change. So be careful. It depends on the system of units. Medium, yes, because the dielectric constant decides how strong the field will be, and that's how accordingly the k value will change. Which of the following is not a property of equipotential surface? Which of the following is not a property of equipotential surface? That is the question. Think about it carefully. System of unit is basically which one, I mean, are you using Newton, are you using centimeters? That is the meaning of system of units. So 9 into 10 to the power 9 is in SI unit. That is the meaning. Okay, sigma? Cool. Which of the following is not a property of the equipotential surface? They do not cross each other. The work done for carrying the charge from one point to other on the equipotential surface is 0. For a uniform electric field, they are concentric spheres. They can be imaginary spheres. The answer for that is, for a uniform electric field, they are concentric spheres. That is not a property of an equipotential surface. This, remember, for a uniform field, what happens? Please read the question carefully, not the property. It's not which is the property. For a uniform field, for a uniform electric field, basically the lines are going to be parallel like this. Then the equipotential surfaces are just parallel lines to it. These are the equipotential lines, V1, V2, V3. So they are plane surfaces, parallel lines. So definitely they are not concentric. They are not concentric spheres. So this is wrong. Okay, so question was not the property. Equipotential lines do not cross each other, because field lines also don't cross each other. So there is nothing wrong over here. This is perfectly correct. Work done to take it from one point to other on an equipotential surface is 0, because V1 is equal to V2. So there is no work done. So there is no change in the energy also. They can be imaginary spheres. Yes, if we take a point charge, the equipotential surfaces are imaginary spheres. Perfect. So A, B and D were actually correct. What is an equipotential surface? Isn't it imaginary at the end of the day, Niv? Even field lines. Do you actually see the field lines? No, right? These are all imaginary things. It's on paper. So they can be imaginary spheres. It's not an actual sphere which you can touch. You cannot touch an equipotential surface. You cannot touch electric field. Electric field you can experience when it applies some force on some charge. Equipotential surface, you understand it, that oh, it's equipotential because the potential is not changing by some measurement. But it is not a real thing. It's an imaginary thing for our concepts. Yeah, value will not change, so it doesn't depend, right? Only unit changes. So what? No, if unit changes different, okay, think of it like this. Who is that? Different over here. See, if I tell you, will the value of 1 Newton be same in dynes? You will be like, no, sir, 1 Newton will become 1 dyne. No, 1 Newton is not 1 dyne. 1 Newton is 10 to the power 5 dynes. So when it is in SI units, it will have some Newton, it will have some meter, etc. You convert the meter into centimeter. So the power of 9 will change, the value might change, everything might change. So that is the reason why I said this is only true in SI units. This value will change in CGS or FPS system. Is that clear? Is that clear different? Akhilesh, which part? So they can be imaginary spheres. This one is basically, if you take a point charge over here, how will the equipotential surfaces look like? These will be the equipotential surfaces. So can they be imaginary spheres? Definitely they can be. Definitely they can be. Yeah. Replica means duplicate. Replica means similar. Okay, got it, Sachin? Fine. Let's move on to the next one. Everybody understood till here? Give me a thumbs up. Yep. Okay. A metallic plate exposed to white light emits electrons. For which of the following colors of light the stopping potential will be maximum? A metallic plate is exposed to white light. It emits electrons. So for which of the following colors of light the stopping potential will be minimum? Now stopping potential is a function of the incident light's frequency. White light is made of many colors. So you have to think about those colors. That's all I would say. Think about those colors. Come on. White light is made of red, blue, yellow, everything. Come on, think about it. Think about it. See, the correct answer for this, many of you are confused between D and C. The answer is D, it is not C. Red light has maximum wavelength, but energy wise it is minimum. Photon's energy is minimum. Violet light has the shortest wavelength. That is the reason why the energy is maximum. And we know the photoelectric equation. How does it look like? The energy of the photon is the work function plus EVS. So if the stopping potential is more, obviously the energy of the photon should be also higher. So which of the following colors will have maximum stopping potential? The one with maximum energy, that is the violet color. Yeah, white color is made of violet, indigo, blue, red, yellow, orange, red, everything is there. But violet has the maximum energy. Yes, sir, Pranav. Very good. Arjun, single boy, very nice way of announcing that you are single, ready to mingle. Hai na? Very good. I'm pretty sure you will find somebody by that name. Some girl will be there. -- Champa, single girl. Then you can definitely send a message on YouTube and you can live happily ever after. An ammeter of resistance 0.81 ohm reads up to 1 ampere. The value of the required shunt to increase the range to 10 ampere is... You start with Praveen, I'll be sending it, don't worry. What is the required shunt to increase the range to 10 ampere? Guys, what you need to do, the ammeter's resistance is given to be 0.81 ohm. Okay. The ammeter of resistance 0.81 ohm. What is the maximum current it can take? It can take a maximum current of 1 ampere. Yeah. Now, if you apply a shunt resistance, if you put up a shunt resistance, I don't know how much it will be. I'll just put it in parallel. That's what I know shunt does. Okay. And I want to increase the range to 10 amperes. So inside, the current that goes in is 10 amperes. Out of that, 1 ampere will go here. How many remaining amperes will go through the shunt resistance? Obviously 9 amperes. And we know both these things are in parallel. So voltage is going to be the same. So IR is going to be the same. So current is 9. Resistance is RS is going to be, current is 1. Resistance is 0.81. So what is that resistance going to be? Won't it be 0.09 ohm? 0.09 ohm. How many of you said B for Bombay? Very good. Yes, Anvi Naidu, I'll be sending it. Don't worry, bacha. Yeah, first of all, concentrate on this class. Definitely, that is the answer. Guys, I think I should change the title of the session. Looks like many people didn't understand what a replica paper is. I thought it was a very simple word. Now, I think I need to make a video on what a replica paper is. Replica. My replica will be somebody who looks like me, who talks like me, who behaves like me. So replica is something what, is like a duplicate. Something what like a mock. It's a similar name. Yeah? Got it? Okay. Yes, Virat, Rahul, only for you. I'm traveling to back to Bangalore so that I can take the session on the big board. Only for you guys, or else I would have stayed. I had some personal things over here and I'm winding them up today and I'll be traveling. Got it? Yes. Chalo. Let's see. In a coil of resistance of 100 ohms, a current is induced by changing the magnetic flux through it. The variation of current with time is as shown in the figure. The magnitude of the change in the flux through the coil is how much? Definitely I'll take English classes for the next year. But this year English paper is gone. But your English paper is going to come in bit sad. For that I will be definitely taking it up. Don't worry. What is meant by Pandu and Champa? Very good, Satish. For that, Satish, you will have to attend minimum 1 month, 2 months of classes. Then you will get the real feel of Pandu and Champa. Within one day, I cannot explain what Pandu and Champa is. It's a difficult concept, much more difficult than physics. Okay. So the correct answer to this, you will have to think a little bit over here. Why this graph is given of current versus time and how the hell will it give me the change in the flux through the coil? And if you have got the answer as D, let's figure it out if you guys are correct or wrong. And you guys are absolutely correct. Now what happens is the current versus time graph's area. What does this area give me? Does it give me something? I think it gives us something. The area under current versus time. Current into time is amperes into time seconds, which is coulomb per second into second, which is coulombs. So basically it gives me the charge. It gives me the charge, and that area is nothing but half into base into height, which is 10. So 10 by 2, 5 into 5 is 25. So this will be 2.5 coulombs. Now what do I do with the charge? Well, we all know that current is induced EMF by the resistance, and induced EMF is delta phi by delta t. So this resistance comes over here. Current is nothing but the charge which goes per unit time. So that will be delta phi by delta t into R. Delta t cancels. So see guys, what we did, Ohm's law is E by R. EMF is d phi by dt, that is Faraday's law. So current, we just wrote it down as dq by dt. Current, we just wrote it down by dq by dt. Now dt we cancel. So delta q is equal to delta phi by R. So therefore, delta phi will be delta q into R. So what is the charge? Charge is 2.5. What is the resistance? 100. So what will it give me? 250. But what will it be? Webers. So 250 Webers is the answer. So the area under this graph gives me the charge. Yeah. We are coming to section B also. Don't worry. Assertion, reason. We are coming to assertion, reason also. Read this. It's very lengthy. Don't have to read these things. Just read this assertion and reason. That is the main thing, because the options are going to remain the same. An electron has higher potential energy when it is at a location associated with negative value of potential, and has lower potential energy when it is at a location with positive potential. Electrons move from a region of high potential to the region of low potential. This is so 100% wrong. Electrons are negatively charged. Electrons which are negatively charged, they move from a region of high potential to low potential. Wrong. They go from low to high. They go from actually low to high. So 100% the reason is wrong. 100% reason is wrong. Got it? It's the positive charges which go from high voltage to low voltage. So reasoning is wrong. So either it will be C or it will be D. Now you just need to check the assertion, whether assertion is true or false. Electron has higher potential energy when it is associated with a negative value of potential, and has lower energy when it goes to positive potential. I think this is correct. So guys, assertion is true and the reason is going to be false. And what is the reason for that? Well, see guys, when you have a negative charge and you multiply it with a negative potential, the energy becomes positive. The energy becomes positive. So if you have a charge which is negative and you multiply it with a potential which is negative, then the energy becomes positive. So if you have a negative charge and you have a positive potential, then when you multiply it, the energy that you get will be negative. So the energy that you get will be negative. That means it is less. So hence the statement of assertion is definitely correct. Yeah. So remember, whenever you get assertion reason questions, don't read the options because options are going to be the same. Which is the first thing that you will read? Never read the assertion first. Always read the reason first. Always read the reason first, because usually what happens when you read assertion and reason in that order, you will get confused. Always read the reason. That's why I saw reason first, then I understood reason only is wrong. So immediately option A is wrong, option B is wrong. So I have eliminated those two options. Either C is correct or D is correct. Now you just have to see whether the assertion is correct or wrong. That's how you solve this. Understood? Everyone? Everybody with me? Cool. Let's apply this technique for the next one. Propagation of light through an optical fiber due to internal reflection taking place at the core of interference. Refractive index of material at the cladding at the optical fiber is greater than that of the core. So which statement will you read first? Apply that same technique, whatever I just told you, and then see the assertion part. So see, refractive index of the material of the cladding of the optical fiber is greater than that of the core. Well. I think it is exactly opposite. The refractive index of the material of the cladding is not greater. In fact, it is lesser. It is not greater, it is lesser, because if this is the cladding material, I'm just showing it to you over here. This is the cladding material and this is the core. You want the light to get internally reflected. If you want the light to be internally reflected and not refract, that means the refractive index of the core must be higher. The cladding must be lower. Dense to rare. This should be dense medium and then this should be the rare medium. Only then this happens. So option A is wrong, option B is wrong. So automatically C and D only are remaining. Now look at the assertion. Light, when it propagates through a fiber, is due to total internal reflection taking place at the core cladding interface. Exactly. That is the reason why it happens. That is one of the applications directly mentioned in NCERT. So I think option C should be correct. Let's have a look. Yes, C option is correct. Understood, my dear warriors, how to do these questions? Perfecto. Shunt means parallel, Hari Prakash. Yes, it's not B for biology. Okay. Yep. Can we expect a similar paper in boards comparing to the replica? This same difficulty is what you can expect. Same type you can definitely expect. Don't expect exactly so same word did not come. Don't hold me by the neck for that. Shall we go to 2 markers? Ready for the 2 markers? Levels are going to increase. Some questions I'll just show you the solutions directly and we'll discuss over there. I'm not going to sit and write everything. Derive the expression for capacitance of parallel plate capacitor without any dielectric medium between the plates. So watch my derivation class, but if you have not watched the derivation class, please go through NCERT and then watch the derivation class. All right, it will be very, very easy. This derivation starts off with, finding the electric field between the two plates and then, finding the potential difference between them and then finding the capacitance. Just to give you a brief rundown. So this is how it goes. You start by taking two plates, one positive, one negative. Due to the positive plate, the electric field will be, let's say, sigma by 2 epsilon naught. Due to the negative plate, again, there will be a field of sigma by 2 epsilon naught. So there will be a net electric field inside, and that will be sigma by 2 epsilon naught plus sigma by 2 epsilon naught. So that will make it sigma by epsilon naught. So this is the net electric field. So once you get the net electric field, what will you do? You will say that between these two plates, there is some voltage difference. And potential difference per separation or per unit length is basically the field. This is dV by dr is field. So potential difference is V, separation between the plates is D, is equal to the field. So field is nothing but sigma by epsilon naught, Sigma is charge by area. So that is what it will be. Now move this around. So Q will be equal to A epsilon naught by D into V. But we know that Q is equal to C into V. We know that Q is equal to C into V. So comparing both of them, you can see Q is equal to something into V. That something over here is the capacitance. So that's how you get capacitance is epsilon naught A divided by D. Understood, my dear warriors? The question is not to write down the formula. Question is to derive it. So derivations do come. So you should know how to derive it. I just shown the sample to you so you can do it properly in your board examination. Name the device which utilizes unilateral action of PN junction diode to convert AC into DC. Draw the circuit diagram. The answer of A is there in question of B. Answer of A is there in question of B. You got the hint already. The action of converting AC current into DC current is called as rectification. So where a bidirectional current is converted into a unidirectional current. Bidirectional is AC, unidirectional is DC, and the job of a rectifier is to exactly achieve that. And how does a full wave rectifier look like? You should know the diagram and draw it with the center tap transformer showing two PN junction diodes and a load resistance with an output. So show this properly. If you miss the center tap transformer, gone. If you miss two diodes, you would show some 3-4 diodes or one diode, gone. If you miss the load, gone. So make sure it looks exactly how it is there in your NCERT. Got it? Yes. So this is the circuit diagram for that. The storage battery of a car has an EMF of 12 volts. The internal resistance of the battery is 0.4 ohms. What is the maximum current that can be drawn from the battery? All right. Apollo, the chances are very good. That's all I can say. See, I cannot tell you which question might come because nobody can predict that. If somebody could predict that, that person is superhuman. But if some YouTuber is telling you, guarantee this question will come, and only this question will come, nothing else will come, they are making a fool out of you. So please don't listen to such people. Okay. So these are most probable. Understand, everything works on probability, just like Heisenberg uncertainty principle, same thing. These are all probability based things. Remember. AC generator derivation, yes, please do remember that. It is very simple. BA omega n sine omega t. It comes by differentiating the flux with respect to time. It's a 2-3 line derivation. Okay. Optical instruments, I don't think derivations you need to know, just need to know the formulas. Okay. Don't do for optical instruments. Unless it is there properly in your NCERT. I think only for simple magnifying glass you should know. For magnifying glass you should know. For telescope and microscope, compound microscope, it's okay. Okay, just know the simple magnifying glass ka derivation, just know that. The storage of a battery has EMF of this. So guys, the EMF of a battery is 12 volts. Internal resistance is already given as 0.4 ohms. Maximum current drawn, I is equal to E by R. That's it, Ohm's law. 12 by 0.4, 30 ampere, nothing. This is pure NCERT question, exactly. There is nothing great about it. Okay, that's the maximum current that you can draw. That is without load. Whenever maximum current is there, that means the external resistance will be 0. So the only resistance, the total resistance, is the internal resistance only. Internal resistance only. There is no external resistance. Silver wire has some resistance at this temperature and some other resistance at this temperature. Determine the temperature coefficient of resistivity of silver. You should just know the formula and that's it. Wave optics diffraction derivation not needed. Or just know the basics of it, because the actual derivation is much more complicated. What they have done is very vague and very random in NCERT, especially that diffraction derivation. So you can just go through it, but it is not so important, Nakshatram. Okay. All right. So, yep. So silver wire has a resistance of this much. What you will do? You will use the formula resistance at any temperature is R naught into 1 plus alpha into T2 minus T1. That's all you need to do. Resistance, you know, at 100 degrees Celsius is 2.7 ohm. Initial resistance is 2.1 ohm. 1 plus alpha into T2. T2 is 100 minus T1, which is 27.5. That's it. Solving this, you will get the answer. So 27 by 21 will be 1 plus alpha into 100 minus 27.5. So solving this, you will get the value of alpha. The value of alpha comes out to be 0.0039. The value of alpha comes out to be 0.0039. Yeah. Okay. Got it? Malik Turki, just remember the formula of energy density, because energy density also comes in capacitors and even in magnetism. Yes, you should know energy density formula just in case. And the energy densities are equal in electromagnetic waves. Half epsilon naught E square is half B square by mu naught. So please remember it. There is a solenoid of certain length, has a radius of 1 centimeter and is made up to 500 turns. If it carries 5 amperes, what is the magnitude of the field inside the solenoid? Direct application of the formula based question. So magnetic field is nothing but mu naught and I. Mu naught we know is 4 pi into 10 to the power minus 7. Number of turns, do I know it? Yes, it is 500 turns, but per unit length, so divided by 0.5. Remember, this is always turns per unit length. If you forget to divide it with the length, if you forget to divide by the length, gone, your marks will be gone. Current is 5 amperes. So solve this and you will get the answer as 6.28 into 10 to the power minus 3. 6.28 into 10 to the power minus 3 Tesla. Got it, my dear warriors? Yep. In the ray optics, the most important things are reflection of curved mirrors, that is your concave convex mirrors formulas and all those things. Next important thing is lenses and their combination, and the prism deviation and the prism optics. And yes, total internal reflection and its applications are also very, very important. Okay, these are the 4 major subtopics, I would say, which are very important in ray optics. Give the difference between displacement current and conduction current. Yes. So, Jayant, what happens is I have seen many schools, what they do, they deliberately set a difficult pre-board paper and many students lose confidence there. But actually, the board paper might be slightly better than what you might have got in your pre-boards. That is, I'm talking about some general good schools. This is just to make sure that students study, and the actual marks that students get is generally higher from whatever marks you got in the pre-boards. So don't worry if the paper that you saw in your school was slightly more difficult, because there is a deliberate reason for that. Now, the difference between conduction current and displacement current is that conduction current is the actual current, and it is because of actual charges which are flowing inside a wire, like the electrons flowing inside a wire make up the conduction current. Whereas displacement current is not because of actual charges which are moving, it is because of the field which is changing, which behaves like a normal current. So displacement current is not due to the actual motion of the charges, but it is because of the changing electric field. Even a conduction current produces, like a current carrying wire produces magnetic field, even displacement current produces magnetic field. So where did displacement current come from? How did the thought process come from? People saw that just like a wire carrying current produces magnetic field, even electric field changing caused some magnetic field. So people thought, oh, if wire can produce current, wire carrying current can produce magnetic field, and I'm getting magnetic field around this changing electric field. So even the changing electric field is behaving like a normal wire, but it is not having actual charges. So that is why they gave the name displacement current. Actual current, conduction current is given by Ohm's law V by R, whereas displacement current is given by this permittivity formula epsilon naught, rate of change of electric flux with respect to time. Okay, understood? Very good. Yep. In Young's experiment, the width of the fringes obtained of light will be 6000. For 6000 Armstrong is 2 mm. What will be the fringe width if the entire setup is immersed in a liquid of refractive index 1.33. What happens is, I discussed this yesterday also, lambda, which is a wavelength, is inversely proportional to the refractive index. More the refractive index, less the wavelength. Great. And we all know fringe width is directly proportional to the wavelength. If the wavelength is less, fringe width is also going to be less. So therefore, beta 2 by beta 1 will be lambda 2 by lambda 1, which will be mu 1 by mu 2. That is the exact relationship. New fringe width, I don't know. Old fringe width, 2 millimeters. Initial refractive index in air is 1. Final is 1.33. So therefore, beta 2 will be 2 divided by 1.33. Understood? So that's it. So you will get the answer as 1.5 millimeters approximately. You'll get it as 1.5 millimeters. Okay. If you want, you can do this. 1.33 is nothing but 4 by 3. 4 by 3. So this will become 3 by 2. 3 by 2 is 1.5. 3 by 2 is 1.5. Great. Section C, 3 marks. Get ready for it. NCERT is enough for full marks only. But the problem is you cannot just do NCERT and understand the pattern of questions. So that's the reason why you need to solve PYQs. You need to give mock tests. You need to practice some questions from some book or from some video sessions just like this. Only then you will get those marks. At the end of the day, everything is going to be asked from NCERT. So asking a question, is NCERT enough, is not very accurate. Define electrical dipole moment. Is it scalar or vector? Electrical dipole moment. A dipole is, two equal and opposite charges separated by a small distance. And the dipole moment is a vector quantity which goes from the negative charge to the positive charge. It is defined as the charge into the separation, right? So derive an expression for it. That derivation I have already done. So these kind of questions can come, my dear warriors. So this is how a 3-marker question might look like. And they might give you partial marks. For definition, I'm guessing they might give 1 mark. For scalar and vector, maybe they might give half a mark or something like that. And then for derivation, they might give 1.5 mark, something like that. So you will get partial marks for every part. If you're not confident of the entire thing and you know that another optional question you don't know anything, then at least get those partial marks rather than losing out complete marks. Okay, fine. Moving on. Guys, there is one option that you have. Just search for Zero to Hero Shreyas Sir on YouTube. You will find my one-shots for almost all the chapters. I know every student has a requirement for one chapter. Some student will say chapter 2, some will say chapter 3, etc. But in this given time frame, I feel you can just search for my one-shot videos, Zero to Hero, you can search for it, or even Flash series, you can search for it. Your topic will be completed within no time. You'll get that utter super duper confidence in a short time. So please do that. Okay, great. How a galvanometer is converted into ammeter? A galvanometer has a resistance of this, full scale deflection of this, converted into this range. Yeah. So please check out my yesterday's sessions PDF. You will get the modern physics questions as well. So galvanometer is converted into ammeter by connecting a shunt or a resistance in parallel of very small value to it so that it bypasses most of the current. And the rest of the part is very simple. So let's say this is the shunt, something like this. And there is a resistance here, there is a resistance here. The galvanometer has a coil resistance of 15 ohms, full scale deflection of 4 milliamperes. So this is 4 milliamperes. You want to send in 6 amperes over here. So out of 6 amperes, 4 milliamperes is very negligible. So almost 6 amperes will only go through the bypass resistance, the shunt resistance. So now the next thing that you need to do is, when you are in parallel, the voltage which is equal to IR is basically going to be the same. That's why 6 into RS is going to be 15 into 4 milli. Milli is 10 to the power minus 3. So RS will be 15 4s are 60 divided by 6 into 10 to the power minus 3. So RS will be 10 to the power minus 2. 10 to the power minus 2 ohms. So check this out. 10 to the power minus 2 ohms. Use this formula, which is 0.01 ohm. show the diagram, write it properly, and get it. So you should draw diagrams always. So first part, I have not drawn the diagram over here, but I have kept it in the sample model solution over here. Okay, but for the second part, I have shown the diagram, right? So show the shunt resistance, get it properly. You will get it. Everyone with me? Yeah. Great, great, great. Yes. Shunt means parallel. Shunt is basically parallel. Yeah. I want all the students who are attending the class to also attend the class after your 12th standard to say hello and to motivate the juniors, because many of your seniors do attend my classes just randomly or for fun, and they'll come, sir, I'm in second year of engineering now, or I'm second year of science now, second year of medical now, and I remember this topic when you taught it that time, and I just came to say hello. I'm in this college doing this, and this city, and this is how it is in my life. I would feel very happy. The students also will get very motivated. Thank you, Siddhant. Thank you, Siddhant, so much. Sir, one shot 0 to hero is enough for boards. See, Kingsley, I made it from the point of view of J. For conceptual understanding, yes, but from theoretical point of view for boards, it will not be enough. For conceptual understanding, one shots of my 0 to hero is good, very good. Yeah. Okay, guys, it looks like you guys are all confused or very distracted now. Concentrate on the studies. There is board exam just in 2 days. Physics paper. I know you guys are all excited. You guys are all nervous. You guys are all, in different zones, different moods, I feel. So put yourself together, concentrate. Once this exam is done now, then we will all have a lot of fun. There will be lot of sessions for bedside, and then your J advance and second mains attempt result sessions. So many things are going to happen. So, but for that, we need to do things properly, whatever we are doing, right? Yeah. Write the 3 points of differences between para, dia, ferromagnetic materials. Yes, para susceptibility is very negative, dia susceptibility is small positive, ferro it is largely positive. You can give examples of them in the end. Always give examples, and then also talk about para will repel external magnetic fields, dia will weakly attract it, ferro will strongly attract it. Yeah, that is one common difference which you can put for dia, para, and ferromagnetic. Yeah. Then you can also talk about diamagnetic materials. What is it based on? Diamagnetic materials is based on the concept that there is no net magnetic moment for the atom, right? And the electron pairing happens completely. So there is no imbalance in terms of magnetic field. All the electrons' magnetic moments cancel each other. Whereas in paramagnetic materials, the atom itself has magnetic moment because there are some unpaired electrons which give you a net magnetic moment. In ferromagnetic materials, it is the magnetic domains which give you the sensation of permanent magnetism, and all the atoms or the molecules inside a domain have a magnetic moment in a peculiar direction, right? And dia and para are temporary magnetic materials, whereas ferro is a permanent magnetic material. So these are the 3 points I have given here, but you can also put up a point on susceptibility. You can give examples of dia, para, and ferromagnetic materials as well. Got it? Okay, great. Given figure shows long straight wire of circular cross section carrying current I. Calculate the magnetic field inside and outside. This is in derivations. Please check out my derivations class. How many of you have seen my derivations class? Put up a red heart. I want to see. Come on, spam in the chat box. How many of you have seen that 6-hour long video which I had posted? How many of you promised that, sir, I will see it now? Then put the word promise. Then put the word promise. Sir, I did not know about it. Sir, I will see it now. If you have seen it, put a red heart. If you are going to see it, then put the word promise. Srinivas, I'll be coming to Bangalore by tomorrow, and immediately I'll be taking the class. Yes. So please check out the derivation. So these kind of sample questions will come. These are 3-marker questions. Define the term wattless current. Remember yesterday also this question came, wattless current. Exactly same thing. So VI cos phi is basically your current which is going to be giving the energy losses, and then you have VI sin phi etc., which gives you which gives you reactive power, which does not consume only any energy. We have done this yesterday. Please check that out as well. Okay. A prism is made of glass of unknown refractive index. A parallel beam of light is incident on a face of the prism. The minimum deviation is measured to be 40 degree. What is the refractive index of the material of the prism? The refracting angle of the prism is 60 degree. Prism is placed in water. Predict the new angle of minimum deviation for the parallel beam of light. Okay. Yes. So for this kind of questions, you have to just depend on the formulas, nothing else. See guys, for minimum deviation, right, what will happen is R1 internal angle will be equal to the second internal angle, which is angle of prism by 2. So it will be 60 degree by 2, which is basically 30 degree. Refractive index is sine of angle of incidence. The angle of minimum deviation is measured to be what, 40 degree. What is the refractive index of the material of the prism? Okay, so then I can write delta is equal to I1 plus I2 minus A. Now deviation is going to be 40. I1 and I2 both will be equal for minimum deviation, so it will become 2I1 minus your A is basically 60 degree. So basically it will just become 2I1 is 60 plus 40, which is basically 100. So I1 will become 50 degree. Is that right? Everybody with me? Now once I get that, what will I do? Mu is equal to sine of I1 by sine of R1. So it will become sine of, it will become sine of 50 degree divided by sine of R1. What is R1? 30 degree. Sine 50 is almost like sine 45. Sine 50 is almost like sine 45. So you can almost approximately say it is 1 by root 2. Sine 30 is 1 by 2. So it will become 2 by root 2, which will make it root 2, which will make it 1.4. But because I took approximate value, I think the actual answer will be close to 1.5. Actual answer will be close to 1.5. So I think the refractive index will be 1.5 because I took sine 45. I took sine 45 as 1 by root. So this would be sine 45 by sine 30. That will give you 1 by root 2 by 2. That is 1.4. So actual value will be slightly higher because sine 50 will be slightly more than sine 45. Yeah, very good. So I think it should be 1.5. Yes. Yeah, it is 1.5 approximately. So for the new thing, you can use even this formula, guys, which you would have already studied, where the refractive index is nothing but sine of A plus delta by 2 by sine of A by 2. So if you take the old one and the new one and divide it, then this term will get cancelled because angle of prism has not changed. Only this term will remain. Only this term will remain. That is what you actually see over here. That is what you actually see over here. And you can easily derive the new angle of deviation. You can get the new angle of deviation. Is that okay? Yes. Is the answer 1.5? Yes, definitely. So you can also alternatively use this formula. Mu is equal to sine of A plus delta minimum by 2 divided by sine of A by 2. You can also use this. There is no harm. And then you can find mu prime by mu is equal to this sine of this divided by sine of this. When you divide them, you can get the new angle of deviation. Got it? Because you know the new refractive index, you know the old refractive index, you can just divide them. Cool, guys. Will you be able to do it? Perfecto. Let's go on to the section E, the final section, case study based questions. Ready for it? I think many of you are also looking for some case study based questions because, you know, many people find it a little bit tricky, sometimes hard, sometimes you do not find enough material on the internet as well. Draw a ray diagram for the formation of an image of a point object by thin double convex lens. Okay, perfect. Having radius of curvature R1, R2, hence derive the lens maker formula. Converging lens has a focal length of 10 in air. It is made of a material of 1.6. It is immersed in some liquid. Just 1 second. Yeah. Some liquid of some refractive index, find the new focal. Drawing the ray diagram, straightforward. This is how the ray diagram looks like. Okay. So from the object, the rays are incident on the first surface. They get refracted to the second surface and then again get refracted. And that's where the final image is formed. Now, when you want to derive the lens maker formula, so the derivation is right present over here, you have to use the curved surface refraction formula 2 times to derive it. You have to use the curved surface refraction formula 2 times to derive it, and then finally, after all the math, you get the answer. If you love derivations, fine, you can go through it, you can get it. But if you don't understand it, it's okay, put it in option and then go to the other optional question. That's what I would say. Okay. So usually for these kind of questions, what you do is this: use curved surface refraction formula 2 times. Meaning these are the two curved surfaces. The ray of light will come parallel because you want to find the focal length. First time it will get refracted. Second time it will get refracted again and it will meet here. So something like this. So the object, you take it as minus infinity. This is the first image after the first refraction. And that image will now behave like the object for the next refraction. And this is where the final image will be formed. That final image, which is formed after the second refraction, is actually the focal point of that particular lens. So you have to use this formula. Mu2 by V minus mu1 by U is equal to mu2 minus mu1 divided by R1. Use this. Mu2 I know is the material of glass. V I don't know. Mu1 is basically refractive index of air, which is 1. U is object distance, so it is minus infinity. So this will become mu minus 1 by R1. So 1 by infinity is 0. So you will get mu by V1 is equal to mu minus 1 by R1. Then you do the same math for the next surface. Same thing for the next surface. Now the image will become an object. The image will now become an object and then apply the same formula. So this time mu2, this time when you apply this formula, mu2 will be 1 and image distance will be the focal length minus mu1 is the refractive index of glass and object distance will be the previous one's image distance. That's how we do it. Is equal to what is it? Mu 1 minus mu divided by R2. So from this you will get the answer solving this. So 1 by F is equal to mu by V1 plus 1 minus mu divided by R2. But I just know mu by V1 is nothing but mu minus 1 divided by R1. So this is 1 minus mu divided by R2. And lastly, take mu minus 1 as common. So this will be 1 by R1 and this will be minus 1 by R2 because 1 minus mu is negative will be mu minus 1. So that will be 1 by F. So that's how easy it is to derive this particular lens maker formula. Okay. I hope I was very crisp about it, right? This is an overview of how you derive this lens maker formula. Okay. And then you can use that lens maker formula for solving the question. Lens maker formula for solving the question. Great. Another case study based question. Look at this paragraph. Look at this paragraph. Read it. Take your time. I'll give you 1 minute or 2 minutes. This is the last question, paragraph based question. It's basically on PN junction diode. Most of it you already know. So if you want, you can take a screenshot of it. Sri Harish had given the weightage of the physics questions, on day one. In fact, you can also get it online very easily. It's not that difficult. Okay. So in the given figure, the diode is connected to an external resistance. Let's straight away go to questions, my dear students. Okay. I hope you have taken the screenshot of it. EMF is 3.5 volt. The barrier voltage across the diode is 0.5 volts. The current in the circuit will be. So the barrier voltage across the diode is 0.5 volts. This is 0.5 volts. So out of 3.5, 0.5 volts just went off in the diode. So the remaining 3 volts is developed across the resistor, and V is equal to IR. So 3 will be equal to I into resistance, which is 100. So I will be 0.03 amperes, which is how much? 30 milliamperes, which is nothing but 30 milliamperes. Very good value. Yep, very good. Karthik, the PDF will come later on, but for now, just go through this video. The PDF might take some time, but yes. For now, just watch the video. Okay, in the PDF, what happens is sometimes you keep on waiting for some PDF, and you end up losing time. I would say watch the video. That is better. You can pause it at any time and solve it. In which of the following figures the PN junction is reverse bias? Reverse bias means the P side should be connected to a lower potential, N side should be connected to a higher potential. Just with theory, can you pass? Yes, you can definitely pass with just theory. That's not a problem at all. That's not a problem. If you skip the numericals and the derivations, you can pass, because theory will be, if you know the experiments, if you know the give reasons, yes, you can. So, which is the correct answer? A, B, C, or D? Is capacitor filter important in full wave rectifier? If they ask you how do you reduce the ripple effect, then you put it. Else, it is not needed. But in general, you can just add a capacitor and keep it, and just mention the word that capacitor is used for filtering. But if it is a small marker question, like 2 marks or 3 marks, then I would say please don't draw the capacitor unless it is asked. If they ask you what is half wave or full wave rectifier, just draw the simple diode based diagram. No need to draw the capacitor. If it is a big question, then you will put the capacitor and say that a capacitor can filter, stabilize the voltage and remove the ripples of the current. Yes, the correct answer is option C, because this is 0 volts ground, this is 5 volts, this is P, this is N. N is higher, P is lower. Is that right? Yeah. Nakshatramanki, grounding means, first of all, the symbol of grounding is this. So when you take any conductor and there is some charge on it, and you take a wire and connect it to earth. Now earth is also an approximate conductor. All these approximate conductor, and because the radius is huge, imagine when the radius is huge, then the potential almost becomes 0. It has a huge capacity to accommodate charge, to accommodate the charge. So if you take 2 conductors and connect them with a wire, what happens? The charges flow from high voltage to low voltage. So if you take a conductor and connect it to earth, this is at a high voltage. Example, earth is at, because the radius is huge, the potential is 0, so it is at 0 volts. So what will happen? Immediately current will flow from high voltage to low voltage. So these charges will go away, and this conductor will get rid of those charges. So that is basically earthing. So when there is excess charge on a device, you take a wire and connect it to earth. That device has some potential, the earth has 0 volts. So due to the voltage difference, the current will flow and will remove those excess charges, residual charges on the device. This is called as earthing. And this is also used to prevent shocks. So if you have an electrical appliance with metallic bodies, so if there is a earthing wire, So the excess charge is absorbed by Earth, thereby protecting you from the shock which you might get by touching those metallic surfaces. Lucky, my name is Captain Shreyas. Got it? Yeah. Darsh, I'm very happy you opened the book 3 days before, at least not 3 hours before, because I'm planning to conduct one class early in the morning. Okay, not late night. Many students told, sir, please don't take late night class. No problem. But for legendary students, okay, I'm going to conduct a special class. It's going to take me a lot of time. I will be, uh, traveling like crazy. And now also I'm taking class. Immediately I'm going to be traveling, and then again after I reach, I will be taking your marathon tomorrow, and then again I'll be waking up without sleep and again taking a class. So you have to be there in the morning on Monday for the legendary students. If you're a legend student, only then attend the class. If you are not a legend, if you're a peaceful student, no need to attend the class. Yeah. So please don't attend any night class that day. I think sleep is important, but waking up early is fine rather than sleeping late. So please don't. Based on the VI characteristics of the diode, we can classify diode as a bilateral, ohmic, non-ohmic, passive element. Yes, C for Captain Shreyas. Don't just say C here. C for Captain Shreyas. So then what happens is people like Lucky will not ask, sir, what is your name? They'll be like, yeah, we already know. C for Captain Shreyas. Perfecto. C for Captain Shreyas. Two PN junction diodes can be connected in series in 3 different methods as shown. If the potential difference in the junction is same, then the correct connections will be. They are connected in series by 3 different methods as shown. The potential difference in the junction is same. Then the correct connection will be. Think about it. Think about it. Yes, in circuit number 2 or circuit number 3. Yeah. Either both are in forward or both are in reverse. Then they will behave similar. If one is forward, one is reverse, then one will try to conduct, the barrier will be less. The other will try to oppose, the barrier will be more. So the voltages will be different. But if both are in forward, both are in reverse, then what happens? The barrier voltage will be same across them. So the voltage difference across both the junctions will be same. Hence it is B option, that is circuit 2 or circuit 3, where here both are in forward bias and here both are in reverse bias. Here this is forward, this is reverse, this won't work. Correct. The VI characteristics of a diode is shown. The ratio of the resistance of the diode at 15 milliamperes to the resistance of at voltage is equal to minus 10 volts is the ratio of the resistance of the diode at 15 milliamperes to the resistance when the voltage is minus 10 volts. So one point is right over here, one point, and the other point is right over here. 10 milliamperes means here. So these are the 2 points. Resistance is voltage by current. Voltage is 0.5. You can see that right over here. This is the voltage, 0.5. Oh no, is it 0.5 or 0.7? I think it is 0.5. Yeah, 0.5. Yeah, but divided by current. Current is 10 milliamperes. So 10 into 10 to the power minus 3. Similarly, at this point, the voltage is basically 10. The current is nothing but 1 micro. So 10 to the power minus 6. So this is basically your R2 and this is basically your R1. So divide both of them and see what is the answer that you get. Divide both of them and see what is the answer that you get. So divide R1 with R2. Divide R1 with R2 and see if you get 10 to the power minus 6. What happened to that 0.5 then? 15 milliamperes. So sorry, it was 15 milliamperes. My bad, guys. It was 15 milliamperes. So I think I took the wrong value. Yeah. So this is 15 milliamperes. This is the one which we have to take. So R1 will be 0.7 by 15 into 10 to the power minus 3. So do the math. Yes. Now divide R1 with R2 and see if you get it as 10 to the power minus 8. Oh, by the way, let me also tell you, there are a lot of surprises which are going to follow in the days to come. Right for your JEE and your NEET attempts. So if you're a JEE student, yes, there will be something really amazing which will be planned for all of you. And if you're a NEET student, obviously you have even more time. There are many things planned for all of you. But if you want to, study with us, you want to see how things are running, I would say after your Monday's exam, just go ahead and visit any of the Vedanta offline centers at so many places. Right now I'm in Pune. I was looking after the Pune center for some days. I'll be soon visiting Tamil Nadu and Telangana. A lot of my students are there, and I'm waiting eagerly to meet all of you. So, there are a lot of things planned for all of you at these centers. Already teachers are there. Many students are going there and asking their doubts, getting it cleared. And I'm not asking you to go and do time pass over there. I'm asking you and go and study. If you go and ask a doubt, still I'll tell you, even if you're not a Vedanta student, teachers will help you over there. So I want you to experience that. I want you to feel that over there, and how much we care about your results and your marks more than you, I think. So we are more bothered about your marks and results than what you might be thinking of. So go experience that at any of the offline centers running in your city or near your city. And yes, all the Telegram channel links are there in the description box. Join it for getting the updates and the PDFs. And yes, there are links as well in the description box for your study material for your CBSE board examination. If you have not yet downloaded those materials, please do that right away, right now. Okay. Yeah. So these are some of the high probability, high weightage questions. Let me tell you, Parkhayon. So I hope you guys enjoyed it to the fullest. And tomorrow we'll see in the marathon revision sessions. And yes, we will also have a special session in the morning. What is it? We'll come to know probably tomorrow. Bye-bye. Take care. Have a lovely, lovely day. Take care. Bye-bye. Hasta la vista. And yeah, do not forget to like and comment. Yes, do that right now. Bye.